Hello everyone. Let us try to understand the question first. There are two resistances. The resistance value R1 is 100 plus or minus 3 ohm. The resistance value R2 is 200 plus or minus 4 ohm. Now, these two resistances are first connected in series and then connected in parallel. Now we have to find out the equivalent resistance of this combination when they are connected in series combination and in parallel combination. Okay, they have given the relation to find the equivalent resistance. When connected in series, it is R1 plus R2. When connected in parallel, it is 1 by R is equal to 1 by Rn plus 1 by R2. Let us find out the answer now. Given data is R1 is equal to 100 plus or minus 3 ohm and R2 is 200 plus or minus 4 ohm. This is the given data. Now, they gave one more relation also. That relation is R series is R1 plus R2. R parallel is 1 by R parallel is equal to 1 by R1 plus 1 by R2. And they gave the relation for finding the error also in parallel combination. That is delta R parallel divided by R parallel square will be is equal to delta R1 divided by R1 square plus delta R2 divided by R2 square. This is the given data. Now we have to find out the final resistance when they are connected in series, when they are connected in parallel. First, let us find out the series connection. Okay. See, in series connection, what is the resistance formula? R series will be is equal to R1 plus R2. Correct? When two physical quantities are being added, the resistances or the errors will be added. So, R series will be is equal to R1 is 100 plus or minus 3 ohm plus R2 is 200 plus or minus 4 ohm. So, resistance should be added. 100 plus 200, it is going to be 300 plus or minus. When two physical quantities are added, their errors should also be added. So, 3 plus 4, 7 ohm over. This is the final equation when two resistances are connected in series. Clear? Now, let us find out the parallel combination equivalent resistance and also the error in it. Okay. In parallel combination, what is the formula for resistance? 1 by Rp is equal to 1 by R1 plus 1 by R2. Or else we can also write it as Rp is equal to R1 R2 divided by R1 plus R2. Now substitute. Rp is equal to, what is R1 value? We are taking only resistance value now, not errors value. R1 value is 100 into R2 value is 200 divided by R1 plus R2 is 100 plus 200. We are going to get Rp value as 66.7 ohm. Okay. Now we got the resistance of parallel combination. See here in series combination, R series is equal to resistance plus error. Correct? This is R1 plus R2, so 100 plus 200, 300 over. And error is 3 plus 4, 7 ohms. Now in the same way, R parallel will also be represented as one resistance value R plus or minus error in the resistance while we connected in parallel. Correct? Rp plus or minus delta Rp. Rp value we got now 66.7. Now delta Rp we have to find. To find this delta Rp only, they gave this relation. Okay. So from this relation we have to find out the delta Rp value. So from here I can write it as delta Rp is equal to, from this equation I am going to write it as Rp square divided by R1 square into delta R1 plus Rp square divided by R2 square into delta R2. Observe properly. See, Rp square came this side. So Rp square came this side. Rp square divided by R1 square into delta R1 plus Rp square came this side. Rp square divided by R2 square into delta R2. Now substitute the values. What is Rp value? 66.7 divided by R1 value. It is R1 value, how much they give? See, 100. Correct? 66.7 whole square divided by R1 is 100 square into delta R1 is 3 plus Rp square 66.7 square divided by R2 square. R2 value is 200 square into delta R2. Delta R2 is 4. This, if we simplify, we are going to get the equation as simplified as 1.8. So Rp is equal to Rp plus or minus delta Rp. Delta Rp value is 1.8 and Rp value is 66.7. So finally, how we wrote in series combination, resistance plus error. In parallel combination also, Rp is equal to 66.7 plus or minus 1.8 ohm. This is the parallel combination resistance value. Okay, thank you. Just look at the whole thing once. Thank you.